Hey everyone, welcome back to 197 Concepts. In this video, I will be discussing with you how to design the schematic capture of a full wave rectifier and how to convert the same circuit into the ready to print format. Okay, so without any delay, let's start the video. So before going into the circuit, you have to know what is a full wave rectifier. So a full wave rectifier is nothing but it's an electronic circuit that converts the positive half cycle and the negative half cycle of an alternating current into the positive DC pulsating current. Okay, so you will be getting an DC output, but that DC output will not be stable. It will be pulsating. That means you will be having waveform like manners, waveform like structure in the wave output will be like pulses, okay, in the output side. Now for this thing, what we are going to do is we are just going to take 4 diodes. So I'm going to use the bridge rectifier. So there are 2 ways for designing the full wave rectifier, that is by using center tap transformer and by using a regular transformer. So if you're using center tap transformer, you just need what we say 2 diodes, but I'm going for a regular normal type of transformer. So for that, I will be needing 4 diodes. So I will be needing a bridge of diodes. This one, this is the one, this is the one, and this is the bridge. That's it. This is the bridge. And for this, what I'm going to do is I'm going to connect for a step down transformer like this. And yeah, these are some specific points where you have to connect the output and you have to connect the input. So between these 2 points, what I'm going to do is I'm going to connect our load resistor, and from here I'm going to connect it to the oscilloscope to check the output. And for this part, what I'm going to do is I'm going to connect the alternating current that is having a voltage of 220 volts with a frequency of 50 hertz. Okay, so this is the circuit diagram, and I hope this circuit diagram is clear for you. It's a very simple circuit, but when you go for designing it in the Proteus, it might get complicated because of this bridge diode. So just check this once. Let us try this once. Okay. So without any delay, I'm going for the Proteus part. Yeah, the waveforms. So at the input, what you are going to do is, so at the input, what you are going to do is you are going to give an alternating current. Okay, so this is the input, and so when you observe the output, positive cycles will come as it is, but the negative cycles, they will, you will get a waveform like this. Okay, so observe this. This part has been converted into the positive part. Okay, so that's the thing we have to observe here. So for the designing part, I'm going to use the Proteus 8 software. Okay, and as usual, going for the new project, and here selecting the path, I'm going to create a new folder on the desktop with the name of full wave rectifier. Okay, so yeah, selecting this folder, and of course full wave, project name is full wave. So I'm just clicking on next. I'm not changing any type of layout things. I'm just going to click on finish. So yeah, this is our circuit, this is our design area, and the components that I need are nothing but a transformer, that is a 2 pole, 2 secondary, 2 primary and 2 secondary, Then there is a center tap transformer also. We will see, yeah, we will simultaneously do this. Okay, and I need diode. So this is enough. So diode and a resistor, generic resistor. Of course, I do need V sign. That's it. So the first V sign 1 and 2, then the two primary, two secondary transformer, connecting it to this part, and yeah, two primary and three secondary. This one, the diode bridge. So this is simpler part. So I'm using only two diodes. As I'm using a center tap transformer, I only need two diodes, and along with that I just need one resistor for the load part. And yeah, of course I need oscilloscope to check the output and the input. So output I'm going to select it at A, or else I will select this as B. The output will be checked at B, connected to channel B, whereas the in will be connected at channel D. For this, I think you believe we can rename this. This is center tap. Okay, and yeah, the center tap, it has to be connected to the ground. No, that's the default terminal mode, ground, and that's the ground. So setting this, I'm going with the default values like 20 and 100. Okay, yeah. Coming to this part, I need to design the bridge. So I need a ground here also. Let me place a ground here. Then I need an oscilloscope also here. So just the oscilloscope and connecting the input to channel A. And now what I'm going to do is I'm going to place a resistor. So of course I need a resistor, and I need to design the bridge. So D3, D4, D5, and D6. Okay, and the transformer input has to be connected between D3 and D4, whereas the other terminal of transformer will be connected between D4 and D6. So D3 and D5, and the output will be collected from D3 and D5 like this, and the other pin will be grounded just like this. Okay, and the output, it will be collected at B2, the channel B. Okay, so this is the complete setup. Yeah, I need to give the values here. This is 20, and frequency I'm selecting it as 100. I'm going to rename this as regular. Okay, now let me start the simulation. Let's see. So center tap transformer, I'm getting some output. So center tap transformer, when I observe this, what is happening here? I am not getting a proper output. So maybe I just need to reduce this value to 1k. Let us focus on one first. uh, oh yeah, I made a mistake here. I need two resistors here. One will be connected here, and the other will be connected here. No, let me check this. Yeah, but the negative cycle is getting completely off. It's not. I'm not getting the. Uh, it's not getting converted. Okay, so there will be a minute mistake. No, I'm still getting it the same way. So maybe it's because of this. I'm going to reduce it to 1K now. Let me check it. No. Mhm. Yeah, by using center tap transformer, my thought was right. So the D1 is only the the channel B is only getting the output of that part. So what if only this part, only this upper section, whereas the channel C is getting the output of only this section? What if I let it be this way? If I connect it to channel D and take the simulation, so channel D is connected to ground, so you won't get the output. So what I'm going to do is I'm just going to overlap all the three here with the same readings, 5, 5, and yeah, that's already 5. So if you overlap all these three, see, you are getting pulsating current for both the uh, what do you say, both the cycles, positive and negative cycles. Now my doubt is, so that's a little bit problem here. Now my doubt is why I'm not able to get the output here. Okay, so you're getting the input, but you're not getting the output. Have I made the connections proper in the bridge? I don't believe. I believe there are some mistakes here. So yeah, let's try to clear it with the built-in bridge. Okay, if you place that particular bridge here, so okay, I place it. This has to go down. The diodes, these diodes has to be in this manner. Now this completes the circuit. Okay, For the positive cycle, for the positive half cycle, you will go in this direction, okay, from D5, then you will go here, from R2 you will go to the ground, okay, or else not to the ground, or from here to D6 and then back to the transformer. So let me run this. I will be getting a flat line, I believe. No, I'm getting a proper pulsating output. So this is by using just regular transformer, I'm going to get only one wave. Okay, so this is much easier representation when you compare this one. So here I need two different graphs because I'm working on two different sections. Whereas when you check this one, it's only one graph. One graph is enough to represent both the things. Okay, so if you have observed here, for the positive half cycle, I'm getting a positive pulse, and for the negative half cycle, I'm also getting a pulse. Okay, so better to go with a regular bridge diode instead of this part. So I'm just going to delete this. Okay, so this is the thing, and we have to develop a PCB for this part. Okay, so just going in the PCB layout. Yeah, we need to do some necessary changes here, right? So I'm going to select this all. I'm going to just block copy, and I'm pasting the circuit here. And then what I'm going to do is I'm going to delete this. I'm going to delete this. I do need the ground, so I'm going to keep it that way, and I'm going to delete this. Okay. Now, when I go in the component mode, I need a 2-pin header. I need a 2-pin header. That's a 3-pin. So it's a 26 number. That's a 1-pin. That's a 2-pin. Okay. I need a 1-pin header also. I need a 2-pin header. And to check the output, I will be needing a 2-pin header. That's it. So yeah. Okay. Now the 1-pin header, what I'm going to do is, so this, I'm going to finish this off neatly like this. So in order to check the outputs, yeah, I have first of all the 1-pin header. I'm going to keep it like this, rotate it in clockwise direction, and I'm connecting to this like this. I'm going to rename it as ground. Okay. Now the transformer input, for that I need two header pins. First of all, this one. So do I need two or three? I need three header pins for checking. Yeah, two is enough. So for that, this is rectified out. Okay, REC. That is rectified out. And no, what I'm going to do is I am going to keep this as transformer in or bridging. Yeah, it's too long. I am going to keep it as transformer out. Okay, and another pin for this, what I'm going to do is I'm going to keep it as rectified out. So rectified out, I'm going to connect it like this, and these two secondary pins, these are going to be connected to ground. Okay, yeah, I need one more here to keep the transformer bridge input. So yeah, rotate it 180 degrees, mirror in y-axis. For this, what I'm naming it as bridge in. So these pins will be connected to the input of the bridge in this manner. Okay, and yeah, from here I'm going to select this one. Okay, so this is the complete circuit that we are going to make a PCB of. So in the PCB layout, first of all, the very first thing that I have to do is place a box, and later we are going to, of course, we are later going to sorry, it's a top silk. So later we are going to resize the box. Now by clicking on Autoplacer tools and Autoplacers, all the components, I don't need all the components, I just need D1, D2, D3, D4, D5, D6, D7, D8 are not needed, ground is needed. I need R1. Yeah, these are the things I need. Okay, okay, and there you go, they are placed here. So D3 and D4, that's in the upper part. So there I have D3 and D4. So D8 and D7. Why not just rename it? So D6, D5, D5, D6, D7, and D8. D7, yes, and D8, yes. And here I'm changing these as D3 and D4. So those are the things. Now if you go for here, so the names has been rechanged, the names has been changed, and I'm going to deselect or delete the D7 and D8. So yeah, now what I have to do is I just have to place my components properly. So rectified output, drag this object here and rotate is anti-clockwise such that you get the gold part here, and TF out, this has to be placed in the top of this. First I'm going to check the TF out, and then I'm going to check the rectified out. Okay, so pin 2 is connected to ground, then R1 is the output resistor. Yeah, I don't need to buy, I just need to go into component mode. R1, what I'm going to do is I'm going to select it like this, and I'm going to rotate in anti-clockwise direction. So my connections are clear here. Then ground, I will just place it somewhere here itself, so it will be easy for me to connect it. Now the bridge in has to be somewhere here with anti-clockwise rotation, and this one, yeah, I need to move this label. So for that, bridge in rotation is 0 degrees, and no, that's a component rotation. I don't need the component rotation. I need this part, the label part, to be at 0 rotation, and I will be moving this downwards like this. Okay, so this will give me a clear idea. Now the hardest part, placing the bridge. So D1, yeah, D1, then D2, I believe it's in the opposite direction. Yeah, D1, then D2, D3. Okay, so the component is missing there. Yeah, D3. Is it upwards or downwards? It's downwards, like this. And finally, the D4 resistor, the D4 diode. So this is the placement of the components. Okay, so I've completely placed it. I can keep this a little bit closer so the board will be much smaller. Now I just need to route them. So I'm going in the track mode, and the very first thing that I'm going to connect is, yeah, I have to connect this one. But before that, I have selected the bottom copper here, and I am going to connect these diodes, all the four diodes initially. So this will give me a clear view or a clear understanding how my board is going to be connected. Okay, so all four diodes are connected here, and from this part I need transformer out is connected to where? Okay, it's connected to bridge in, so I can do that later also. This one is a direct connection, so yeah, why not do it like this? Okay, now I need to connect this up to here. So for that, I'm just going to pass it from here, and inside I don't have any connection, so I'm going to use this path. Okay, while overlapping, while passing through the components, yeah, it's going to be in the bottom side, so that's not a problem. Like, see here, you will not be seeing the path here, but you will be seeing the path here, so this is not a problem. So when the path is passing through this point, this middle point between these two terminals, you have to be careful such that you have the sufficient space here. And since it is going below the board, it's not a big deal. Okay, so this is clear. That's not a big problem. Yeah, let's go to PCB layout. That has been cleared. Now what I need is I need to connect the, okay, let's connect the ground first. So it's reversed. For that, what I'm going to do is I'm just going to rotate this one. Okay, why is this anode, the D1 anode, connected to ground with the resistor? And that's a ground terminal. So how could I route this easily? No, it's better to keep it in this manner so that I can easily connect it. Yeah, the grounding points of the oscilloscope outputs. Yeah, just click here, click it here, click it there, and sit. And then take the ground, and that's it. So that's the ground point. Now this ground point has to be connected to R2. Before that, I need to check the output. So for that, that's one, and from there to there, that's the final output. Now, yeah, in order to connect the ground, I can just keep it here, right? So this whole part will go and connect like this. That's not a big deal. And this is the connection. And finally, I need to check the diode output. So bridge output. For that, I am going to connect it this way. Okay. So yeah, after this, if you do this, your components are placed like this. Here you are going to give the transformer input, the alternating current, okay, step down alternating current, and from here you are going to see that in a waveform, and then this part you are going to check the rectified output. So in order to get the ground, so yeah, the pin number 1 is where you have the notch. So this is the pin number 1, this is the pin number 2. This particular pin, what we say, yeah, this particular pin and this particular pin are connected to the ground. So that will be easily understandable when you go at the bottom side. See, so this is pin number 2, this is pin number 1. Okay, so that's it. This is the complete layout. Yeah, we need to get a ready to print. So for getting the ready to print, yeah, and one more thing, we do have to resize this also, because we don't need such a big board. Placing it there and placing it there, and I'm leaving some space for the transformer here. Okay, so that's the complete board. This is the complete board, and to get the ready to print, just click on output, print layout, and I need the bottom copper. I don't need top copper. Top resistor is not necessary. I need top silk. I don't need bottom silk. And drilling is necessary. Top assembly is necessary. Print to PDF. Finally, I'm clicking on OK. So here what I'm going to do is I'm going to rename as full wave. Enter, and this will open the PDF. So where is the PDF? This is the PDF. Okay, this is the complete part. So see, if you go for the top silk, if you consider the top silk, what will happen is you will get overlappings here. So instead of that, what we can do is we can just go here. We just need the tracks, right? We don't need the overlappings. Output, print layout, and select here. Okay. Yeah, I don't need top copper. I don't need top silk. Just top resistant, top bar. I don't need that. Okay. Pretend then. So full wave rectifier, bottom copper. So these are the tracks that we need. So it will give you a clear understanding. Okay. For a better idea, let us do one thing. Let us delete all the tracks. Just go in the track mode, select it all, and delete all the tracks. What I am going to do is I am going to design it with the top copper. So for a better understanding, this is completely for a better understanding. Okay. So yeah, let's redesign this all. I'm going a little bit quicker because we have already did this. I'm not going to explain you the connections and all. You have already heard that. So I'm just going a little bit quicker. Yeah, in this case, what we are going to take the track from the center. Try to avoid the edge points because that might short the circuit. So this is the complete circuit. Now, if you observe the 3D visualizer, so you are getting the tracks on the board itself. Okay, so when you go for this and you print the output, This will give you a better understanding of what you need and what you don't need. Top copper, top resist, bottom resist not needed. Okay, so yeah, see. Now, when you place this onto the board, you will get all the values, all the printables, that means the tracks and the D1, D4 at the same time. So why I did this is when I go for this one, okay, so when I go for this one, at the bottom side itself, you will get the tracks and the markings itself. So I don't need the markings at the bottom side. I need the markings on the top side. That means at the plastic side. For that purpose, I have made it as a top side also. I mean, I have designed it with the top copper also. So this is completely my wish. Generally, we go for the bottom copper instead of top copper, but this completely depends upon the designer itself. He can go for top side or he can go for the bottom side. So my suggestion, if you need these D3 and all, take the top silk, take a printout of it, and take the bottom copper, and at the bottom side paste the tracks, uh, imprint the tracks, and at the top side or paste all the things. But just for the representation purpose, just for keeping it as a record, you can take the what we say, the top copper itself. You can design this. You can design it in this manner. Okay, this will be much neater for keeping a track or for keeping a record and all. So this will be much easier for you. So I hope you have understood the process, and that's it in this video. Thank you for watching this video.